Okay, for the first question, we have f from natural number, Cartesian product natural number, map to natural number, f of a b equals to ab times a plus b. If you observe this function, okay, observe this part, you'll see that if we switch the order of a and b, this function stays the same, which means, well, this function is not injective. For example, f of, let's say 1, 2 equals to 1 times 2 times 1 plus 2, which is 6, and this equals to 2 times 1 times 2 plus 1, which is still 6. This means it's, this is 2, 1. This means it's not injective, okay? For surjective, you'll see that for this function, you'll never map to, let's say 1, okay? Because the smallest one you can map to is 2. If we let a and b be 1, f of 1, 1, you'll get 1 times 1 times 1 plus 1, which is 2, which means you'll never map to 1, so there does not exist ab in natural times natural such that f of ab equals to 1. So it's neither. Alright? The next one, I got so many emails asking me for this one. You'll see that this function is not injective. I'll give you a counterexample. Let's say, what counterexample can I think of? Let's say f of 1, 3. Okay, so if we have 1, 3, then 1 times 1 plus 1 times 3, that's gonna give me 6. How else can I make it 6? Okay, I see. 1, 3 equals to 2, 1. Okay, because 2 times 3 times 1, that's 6 as well. Okay, so this is not injective, but how about surjective? I got so many questions asking me, how do I show this function is surjective? Well, one thing you can do is we can fix a to be 1. Okay? If we fix a to be 1, then you will have f of 1b equals to 1 times 2 times b over 2, which will give you back b. Well, since b is any natural number, therefore, for any natural number, for any b in natural number, there always exists a b in natural times natural that map to it, so it's surjective. For the those functions that has more than one variable, fix one of the variable is a really good way to do such questions, and you'll see for number 3 as well. So for number 3, it's easy to see that it's not injective. For example, f of 2, 1 equals to f of 3, 2. Okay, so it's not injective. For surjectivity, again, we can fix b to be 0, then you will have f of a0 equals to a. Okay, since a is any integer, for any integer, you always have something in integer times integer that map to it, so it's surjective. Number 4, well, it's easy to see that it's not injective because f of -1 equals to f of 1. Is this surjective? I think it's not. So it's neither. because you'll see that this function can never map to negative numbers. So there does not exist x in integer such that f of x map to, let's say, -1. Okay, so it's neither. For number 5, again, I think for injectivity it's simple enough. You'll see that f of -1 equals to f of -2. Okay, because if x is a negative number, you'll always get 0. Well, what about surjectivity? Is this surjective? Well, it's not. Because as I said before, if your x is negative numbers, then you always map to 0. So let's say there does not exist x in integer such that f of x is -1. Okay, so it's neither. Number 6, it should be obvious that it's injective, because if you have, let's say, f of x1 equals to f of x2, then you will have x1 squared x1 equals to x2 squared x2. This will give you directly x1 equals to x2, which is injective. But is it surjective? Well, obviously not, because for this guy, you'll never get negative numbers. So there does not exist x in real number such that f of x equals to, let's say, -1, -1. Okay, so it's injective. Number 7 is, okay, let's see. So it's from real to real, so we can just graph it and see what happened. This is gonna give you, so when x is smaller than or equal to 0, so this side will get x, so it's a straight line like this. When x is greater than 0, we have 1 over x, which looks like this. Okay, then obviously it's bijective. Why? Because for injectivity, we can do a horizontal line test as mentioned in part 1. So, horizontal line test, it passed horizontal line test, so it's injective. And it's surjective because, well, it mapped from negative infinity to infinity. Well, you see, if we see this side, you'll see that it will never get 0, but here map to 0, so it actually mapped from negative infinity to infinity. So it's bijective. Number 8, there is a typo. This should be real number here. 2 students came to me yesterday during my office hour and told me, oh, this is not well defined. That's great. You notice that it's not well defined. But originally I meant real to real. And I think injectivity should be easy. Well, if you do x1 to the 5 minus 3 equals to x2 to the 5 minus 3, this will give you directly x1 equals to x2. So it's injective. All 3 will be injective, while this one is bijective. Well, if you draw the graph, okay, the graph should be easy for everyone. Why? Well, we all know what x to the 5 look like. And you move it down, so this is minus 3, so the graph should be something like this. Okay, and you do horizontal line test, you'll see that it's injective, Also, it goes from negative infinity to infinity. So when our domain and codomain are real numbers, this is bijective. But why the other two are not surjective? This is because, well, if we try this out, you'll see. Let's see f of 1 for the first one, okay? F of 1 will give you 1 to the 5 minus 3, which is negative 2. F of 2 will give you 2 to the 5 minus 3. Okay? You see that there is a huge gap between this and this. And this huge gap will never reach to that, will never map to that. So we can give a counterexample here. There does not exist x in integer such that f of x equals to 2. Same idea for the second one. We can say there does not exist x in rational such that f of x map to, let's see, map to 1 over 7. Okay, I think it works. Yeah, it works. Number 9. Again, since our domain is real number for number 9 and number 10, since your domain is real number, we can always draw the graph and do the horizontal line test and observe the graph and see if it's surjective as well, since we never asked you a proof. Okay, for this part we're just asking you if it's injective, surjective, or bijective, so you can just draw the graph and see. Well, for this function, everyone should know the graph. This look like, oh, it will never reach 0, so something like this. Here is 1. By this graph, you'll know that it's injective, but it's not surjective because we'll never get 0. Such that fx equals to 0. Because we'll never reach 0 here, okay? Number 10, well, for number 10, again, we can draw the graph. So we all know what x squared look like. Something like this, and then you can do transformation, okay? So it moved up by 1 unit, and move to the right by 1 unit. So this whole graph look like something like this, okay? So from the graph you'll see that it fails horizontal line test, so it's not injective, and will never reach anything here. Okay, so we'll never reach 0, we'll never reach anything between 0 and 1, so it's not surjective as well, so it's neither. Number 11, I think it's not injective because, well, we have a rational. For rational, we can have 2 over 4 equals to 1 over 2 equals to, let's say, 3 over 6. So there are a lot. Okay, so you can find a lot of counterexample for injectivity. Let's say f of 2, 4 equals to f of 1, 2. So it's not injective. What about surjectivity? Apparently no, because our codomain is real number, but this function can never map to irrational numbers. So there does not exist Kn in that Cartesian product natural number such that f of Kn equals to square root of 2. Okay, number 12. Well, for number 12, you need to be careful because if you notice that they switched order right here, okay? It's M here and here, but they switched the order right here. So in this case, you should know that your n belongs to integer, your m belongs to natural number. Okay? Well, if you look at this, you'll see that it's not injective. The reason is this part, okay? You have a square here, so apparently it's not injective. F of minus 1, 1 is the same as f of 1, 1, okay? Anyway, is it surjective? Well, no, it's not surjective for the same reason right here. This part made it not surjective as well. Why? Well, we'll see. Okay, we'll see that this one, let's make it, there does not exist m and in natural times integer such that f of mn equals to what? So this is integer, so you can have 0, you can have 5, then 2 to the 2 plus 4, that's 8 to 5. In between 5 and 8 there is nothing mapped to that, so you can pick one. Let's see, 6, 1. Okay, number 13, well, it's apparently not injective. Again, if you switch order of m and n, you get the same thing. So f of 1, 2 equals to f of 2, 1. So it's not injective. Is it surjective? Yes, it is. As we said before, we can fix m to be 1. Then f of 1n will give you n, which is any natural number. So for any n in natural number, you can find its pre-image. So this one is surjective. Number 14, it's obviously injective. I'm not gonna prove that. I think it's quite obvious. It's not surjective because, well, those two numbers will never be the same. So there does not exist x in real number such that f of x equals to 1, 1. Okay? Because those two, they always have difference of 1. Number 15. This one is, let's see. This one is definitely injective because it's from natural, so it's injective. Is it surjective? No, it's not surjective. For example, there does not exist x in natural number such that f of x equals to 1. Okay, because the smallest x you can get is 1, so the smallest f of x you'll get is 2, so you'll never map to 1. Number 16. Number 16, it's apparently injective. As a surjective, it's not surjective. Well, look at this, okay? It's not surjective. Well, okay, I feel like I need to explain why it's injective. If you look at this part, it looks like it's not injective. But if you look at this part, well, this is a linear, non-constant function, so it's bijective. If you look at this part, it's bijective, okay? This part make the whole thing injective. So it's injective. But is it surjective? It's not, because if you look at this part, you'll never map to a negative number, so there does not exist x in real such that f of x equals to -1, -1. Okay? Number 17, it's non-constant linear function. Okay, so it's bijective. It's a straight line, so everyone should know it's bijective. Number 18. Number 18. Well, it's injective for sure. It's a bijective. Number 18. No, okay, so it's not surjective because, well, it never mapped to negative number. The graph, I think the graph should look something like this. So you will never reach to negative number. And you can do horizontal line test. You'll see that it's injective. Number 19. Well, 19 is apparently not injective because you can draw the graph out. You will see. How do we draw the graph? We factor it out. This will give you x squared minus 3. So the graph look like something like this. Okay, so this is our graph. It does not pass horizontal line test, so it's not injective. And it's surjective because it goes from negative infinity to infinity. So it's surjective. Number 20. Well, this one you can draw the graph out as well. So let's draw the graph out. We all know what this look like. So this looks like this, and you move down by square root of 2. So the graph will look like this. Okay, so well, you can do horizontal line test again. You'll see that it's not injective and it's not surjective, so it's neither. Okay, because you can never map to anything below negative square root of 2. 21, again, you can do can draw the graph out as well. Okay, so number 21, you'll see that, well, it's a linear. Oh, you don't even need to draw the graph out because it's non-constant linear function. So it's bijective. Well, it's a straight line, like this. Okay. Number 22. Well, it's from real to real again. So wait, number 22. Oh, number 22 is bijective. Well, this is bijective as well. Number 22 is bijective. We proved that in tutorial, so please have a look in tutorial notes. Proved in tutorial. I'm not gonna go over this again. Number 23. Well, apparently this is not injective because f of 0 equals to f of 2. Is this bijective? Let's see. No, because it never mapped to negative numbers, so there doesn't exist x in rational such that f of x equals to, let's say, minus 10. Okay, so this is neither. 24. Well, I think it's obvious that it's not surjective because we'll never map to something weird, like, let's say, that such that f of nz map to, let's say, 7/10. Okay, because everything that's in like rational, like m over n, it looks like 1 over something or something over 1. Okay, so you'll never map to 7 over 10, so it's not surjective. Is this injective? No, it's not injective, okay? Because, well, f of, let's say, 4, 1. 4, 1 is going to give you 4 to the power of 1, which is 4, equals to f of 2, 2, because 2 to the power of 2 is 4 as well. So it's neither. 25. 25, you need to make sure what you understand this. So integer minus natural number will give you all the non-positive. This will give you all the non-positive integer. Okay. So, well, again, we have absolute value. You should know that it's not injective because, well, f of 1 equals to f of -1, so it's not injective. And is it surjective? It is surjective, okay? Because, well, if you look at this, if we want -1, we can get x equals to 1 or -1, doesn't really matter. -2, we can get that as well. -3, any of the negative integers we can always map to, so it is surjective. 26 is an interesting one. Well, if you look at this, you'll see it's injective, okay? If you only look at this, it might look not injective, or if you only look at this, it's not injective. But if you combine those two together, it actually make it injective. I'm not gonna prove it, so you should do it yourself. I think it's simple enough. And it's not surjective. The reason is that, again, those two, okay, they are always different. So there does not exist x in natural integer such that f of x equals to 1, 1. Or so they can never be negative number. So let's use -1, -1. But it's the same thing. Okay, so it's not surjective. 27, we have this again. So this gives us non-positive integer. If you look at 27, apparently f of 1 equals to f of 2, because any positive number will give you 0, okay? But is it surjective? Well, no, it's not surjective, so it's neither. Why? We can write this whole thing as a piecewise function. When x is greater than or equal to 0, you will get 0. When x is smaller than 0, you will get 2x. Okay? Since x is natural number, so you'll see that this can only be negative even number. It can never map to negative odd number. So there does not exist x in integer such that f of x equals to -1. Okay? Number 28, I think it's obviously bijective. Okay, I'll let you to do the work. I think it's quite obvious enough. Number 29, there's a typo here. 29, well, it's from real to real, so you can draw the graph out again. What does the graph look like? 2 to the power of this. Okay, so the graph look like something like this. It's not the same as like this. I think it will be more like this. So it's like sharp here. Anyway, if you draw the graph out, it doesn't pass a horizontal line test, so it's not injective, and it's not surjective because you can never map to like a point here, so it's neither. Last one, well, we have a Cartesian product here. You should know that this means minus 1, minus 1, minus 1, 1, 1, 1, and what else? 1, minus 1. Okay? But on this side, this will give you either 1, minus 1, or minus 1, 1. So, well, it's not surjective. That's obvious. Oh, the other injectivity. Oh, injectivity should be obvious as well because, well, f of 2 equals to f of 4. So as long as x is even or odd, it doesn't matter. Even give you the same thing. Odd give you the same thing. So it's neither. Okay, I think that's it. Yeah, that's it. That's all the questions we have. Please practice more questions. It's really important to practice this part because it's really easy to make mistake. I hope I didn't make mistake. If there is anything, any mistake I made, please let me know and I'll correct it under the comment section. Anyway, good luck on your quiz tonight. I'll see some of you tonight.